Hello everyone, I am Dr. Velamani P.S., Professor, Department of Computer Science, University of Science and Technology, Meghalaya. In this video, we are going to see the Android operating system and its feature and its architecture as well as various applications. The Android advantages, features, architecture, and the Android lifecycle applications are the contents in this particular video. Introduction to the Android. So the Android operating system for mobile phones that is based on the modified version of Linux. So the operating system for the mobile that is actually the modified version of the Linux. Originally, Android was developed by the Android Incorporation. Then after that, 2005, Google purchased the Android and took its development work and also its development team. Google wished that Android to be free and open source that can run on any kind of devices such as mobile phones, tablets, and even televisions. Android is open source software that contains the operation system, middleware, and key applications. In Android, anyone can download the code and can modify the code and can use the code easily. This is the main feature of this Android and the main advantages of the Android. So the Android is the operating system. The stack of software components, which is roughly divided into 5 sections and 4 main layers. So in the architecture diagram, we'll see the 5 sections and 4 main layers. The advantages of the Android. The Android provides unified approach to develop the Android applications. It means that the developer needs to develop only Android and then application can run on different devices powered by Android. So as we already discussed, the Android open source means anyone can download the code and can customize according to their need. The features of Android. So the various features such as live, really simple syndication which feeds the weather, etc., weather details, etc. Then it provides the facility for push notification, the GPS storage facility using SQLite. Then the Android provides the connectivity such as Bluetooth, Wi-Fi, GSM, CDMA, LTE, WiMAX, NFC, etc. The connectivity. Then the messaging facility, SMS, MMS also we can transfer. Then the web browsing, which can be used open source layout, WebKit engine, and it is coupled with Google Chrome and support HTML5 and CSS3. If you are looking the history of the Android, so the initial version was September 2008, the API level or the application programming interface level 1 version 1.0. The core name, there was no code, again there was no code. Then all cupcake, donut, eclair, Ferrero, gingerbread, honeycomb, ice cream sandwich, jelly bean, Kit Kat, lollipop. So all the versions of different Android application programming level, it is somewhere we can find the names and all the chocolate names, ice cream names like that. It's we can see to it. So 2008, 9, then 10, 11, 12, 13, 14, various versions. came to the market. And in continuation to this, Lollipop, Marshmallow, Nougat, and Oreo Pie till up to August 18. Android 10, 11, like that manner it has started. And now Android 14, upside down cake, that is Q3 2023 version. Then Android 15, vanilla ice cream, that is Q3 2024, that will be come to the market in future. Android architecture. So there are four layer levels: application layer, application framework, then the libraries, then the Android runtime, Linux kernel. So each and every layer level, there are certain things which is shown very clearly: home, contact, phone, browser, then the application framework level, activity manager, window manager, content provider, view system. It all about the screen management, the user interface. Then the library, the surface manager, media framework, SQLite, that is the database storage, WebKit, free type, OpenGL, SGL, SSL, and we'll see to it one by one. And Android runtime. So the core libraries, that is Dalvik virtual machine is used in this. Then the Linux kernel, that is the operating system. In this, several drivers will be available like display driver, camera driver, flash memory driver, binder driver, keypad driver, Wi-Fi driver, audio driver, and power management. Everything will be controlled in this Linux kernel. So if you are looking a particular Android mobile, there are different type of sensors also we can see here. So the proximity sensor, then the ambient light sensor, then CMOS imager sensors, GPS sensor, accelerometer, humidity sensor, then the microphone, touch screen, gyroscope, magnetometer, fingerprint sensor, pressure sensor, temperature sensor, all these sensor and all inbuilt in our smartphone, that is Android based. Now the Linux kernel layer level 1. The architecture is based on 2.6 Linux kernel. Android use a Linux kernel as its hardware abstraction layer, the core features on which to develop the Android operating system. There, memory management, the freedom to develop our applications, that will be handled in this particular memory management. So it is the process of controlling and coordinating the device memory by assigning suitable memory blocks to various running programs. Then the process management, it manages the process, well, allocates resources to process whenever there is a need by them. So if the process requires some resources during that time, the resources will be allocated. That is our process management. Then network stack, it is effectively handling the network communication. The driver model, it translates between a hardware device and the operating system, which is helping in running attached hardware. It may be the display, Wi-Fi, and audio. Security, it is the Linux kernel will handle the security between the application and the system. So if you are downloading the application from the Play Store or Play Store, the Linux kernel will take the responsibility to secure the application and the system, our Android operating system. So the libraries, there are several libraries which is already depicted in the architecture diagram. So the surface manager, it is responsible for drawing surfaces on the smartphone screen. Then the OpenGL, ESSGL, This across language, cross platform application, program application interface, which is used to produce 3D and 2D computer graphics, respectively. Media frameworks. It is used to play and record audio and video. Free type. It's a high quality and portable engine. Then secure socket layer. This is a layer, these library layers and all for the internet security purpose used. SQLite, it uses as the core of the most of the data storage. WebKit, this open source web browser engine provides all the data functionality to display web content and to simplify page loading. Then the core libraries, three libraries are very important in the Android operating system. The Java libraries, Android libraries, and the JVM libraries. The standard Java libraries is the must alongside specific libraries for Android to control and access media databases, etc. The JVM libraries are specifically used to interact the Jalvik virtual machine. Android runtime. The ART. It is used to manage the runtime. The ART is the managed runtime used by the application and some system services on Android. So the runtime and system services will be taken care by this Android runtime ART. So the ART and its predecessor Dalvik were originally created specifically for the Android projects. So ART as the runtime executes the Dalvik executable format and text bytecode specifications. Application frameworks. So the Android team has built on a known set prone libraries built in the background. All of it these is exposed to those Android interfaces. These interfaces pop up all the various libraries and make them useful for the developer. The developer can use these libraries for any kind of application development. So bunch of classes and methods also will be utilized for the application developments. Application framework. So in the application framework, activity manager, so it manages the activity lifecycle and the activity stack. So the activity lifecycle, so how a particular application is going to create and going to be processed and executed until the time the application is going to be terminated, that particular thing will be handled by the activity manager. Then the telephony manager, it provides access to telephony services as related subscriber information such as phone numbers. For example, one would require telephony manager to get information like SIM serial number, telephone system sort, IMEI number, etc. Then the location manager, it, it is used to find the device's geographical location. A notification manager, which is used for the user can expand the notification bar, and by selecting the notification the user can trigger another activity. So this class to notify the user of events that happen, altering the user by flashing the backlight, playing a sound or vibrating LED blink, etc. So several processes will be handled. Package manager. So the class for retrieving various kinds of information related to the application packages that are currently installed on the device. Then the view system. So the user interface by handling the views and layouts. Resource manager, which is used to provide a tool to visualize the drawables, colors, layouts across your app project in a consolidated view. The window manager is a system service which is responsible for managing the Z-ordered system of windows. So the windows are visible and how they are laid out on the screen. Content provider. So it manages access to a central repository of data. Applications. The topmost layer of the architecture, the applications are installed in the layer. So all the standard applications, games, messages, contacts, etc., will be considered in this particular layer. A software app that runs on the Android platform is known as Android app. So Android app. So this Android app will download from the Play Store. A standard Android app is built for a tablet, PC or smartphone running on the Android operating system. So as I told that Android apps are available on the Google Play Stores, also known as Android App Store, and multiple Android app focused websites. Activity life cycle. So the activity is one of the building blocks of Android operating system. In simple words, activity is a screen that user interact with. So in this activity life cycle, creation, start, resume, pause, stop, and destroy. These different states will be monitored, and these different states will be happen during a particular activity takes place in the Android operating system, which is known as activity life cycle. We'll see this by using this tabular column format. So the first on create method. So when the activity is first created, so this on create method will be executed. If it is the killable, if it is no, the next method on start will be called. Then on restart, the called after your activity has been stopped prior to its being started again, always followed on start. Again, if it is killable, no on start. Again on start it will take place. On resume or on stop will be hidden in the foreground. Then on resume called when the activity will start interacting with the user. At this point, the activity is at the top of the activity stack with user input going into it on pause. Then on resume, the next call, the system is about to start resuming a previous activity. So this is typically used to commit unsaved changes to persistent data, stop animations and other things that may be consuming CPU, etc. So the pre-honeycomb is the process killable at this moment. Then on stop is a call when the activity is no longer visible to the user because another activity has been resumed and it is covering this one. This may happen either because a new activity is being started and existing one is being brought in front of this one, or this one is being destroyed. Now if it is S, then it will be restarted or on destroy. So on destroy, this is the final call which we can receive before the activity is going to be stopped or destroyed. This can happen either because of the activity is going to be finished. Yes, finally, the next state is nothing. So this particular flow chart will depict the flow very clearly. So when the activity is going to start and when it is going to be shut down. So the first activity starts on create, then on start, then on resume, then activity is running. If the activity is on pause at this moment, another activity foreground will be on resume. Then if it needs some memory also, the process will be killed and again it backs to the creation of the activity. After that on pause, on stop again it will be takes place in the foreground on start, which is comes under the on restart, and at the same time it also needs the memory. The process is going to be finished and back to the activity. So the finally the on destroy the finishing of the process, which is going to leads with the activity is going to be shut down. So this is the flow diagram of the activity life cycle, which we can understand very simply. Thank you very much. Thank you. So in this video, we have seen the Android operating system and its major areas related to history and different type of layers and different type of libraries and the Android activity lifecycle, the major features of Android, everything we have studied in this particular video. Thank you. Thank you very much. Thank you.